Okay, guys, this is the last lesson for Chapter 7. This is on special products. It really piggybacks our 7-6 lesson where we multiplied two binomials together. We're just looking at different setups, different scenarios that we might see when it comes to multiplying our polynomials together. You will need your Skills Practice 7-7 worksheet, which you can find on this Canvas page attached with the video. So let's take a look at the first example. So here we have an expression where we have an entire binomial raised to the power of 2. Now, if we go back and think about what does x raised to the power of 2 equal, we know that's taking the value of x times x. So we expanded on that when we were talking about our monomials. What would happen if I have, let's say, 2ab squared, that whole quantity raised to, in this case, the second power? And in longhand, that says, well, everybody, that means to take 2ab squared and multiply it by 2ab squared. And so that gave us 4a squared b to the fourth power. Now, we did use the idea of, well, everybody gets a piece of that square, and so we had done 2 squared, a squared, and b 2 times 2, which still gives me the same result of 4a squared b to the fourth. So what we don't want to confuse this problem with is some of the things that we have been doing in the past. Okay, we need to really keep in mind of this idea that anything raised to the second power means I need to multiply it by itself, 2 times. And so this little idea here of giving everybody a piece of the exponent with that idea sort of distribution applies only when I have multiplication and multiplication. So we have to be careful here. This is not n squared plus 3 squared, which is n squared plus 9 squared. That is not, or 9. That is not what this says we're going to do. Squaring something is a higher power to multiplication. And so adding is 2 levels away when we think about our PEMDAS. And so I can't jump from exponents all the way to addition. Okay, exponents are next to multiplication in our scale. So we need to use this thinking up here that we have to multiply it by itself. There's no way of getting around it. So this tells us to take n plus 3 and multiply it by itself, n plus 3. So you should be looking at that and thinking, okay, well, we were foiling when we had two binomials together. So this actually means to FOIL. So we take our two terms, our inner two terms, outer two terms, and our last two terms. We simplify that to get n squared plus 6n plus n. Final answer. That is not the same as our n squared plus n. And so it's very important that you keep in mind what it means to raise something to the second power. This idea of the distribution was the shortcut, but that was multiplication, which is what exponential math is, over another form of multiplication. Okay, and so you have to be careful with that. Let's try another one. So looking at this one again, the idea that we have to take all of this and multiply it by itself, so I have to write it out the long way. And I have to write 2y minus 7 times y minus 7. Using FOIL, we're going to take the first two terms, which is y squared. My inner two terms, or my outer two terms, is negative 7y. Inner two terms is negative 7y. My last two terms are a positive 49. Collecting things together, y squared minus 14y plus 49. Now there are some ways that I can look at this in terms of some shortcuts. certainly we're going to have a y squared. We did have 49, okay, but we have to remember about those inner and outer terms. And so when I look at these two, I can see, well, it's a -7 and y. That's what I'm going to be using twice. And so we have that -7y. For those that like their shortcuts, you know, you can do a little mental math and know that it's going to be -7y twice, okay, and simplified. So final answer, y squared minus 14y plus 49. Now, this one is not what we have looked at different. We've looked at this idea in the past, two binomials, but what's interesting is the result, and this will be important when we move into our next chapter. So foiling this is going to say first outer inner last, which gives me b squared minus 1b plus 1b. The last two terms give me a -1. Well, interesting on this one is we do have opposites. And so they actually cancel themselves out for our new answer. And we look at this, and this is actually the difference of squares in this one. And so we'll see that when we have to undo this. Next chapter is taking this and moving backwards to get that first expression where we actually have to pull it back apart. But, you know, the idea that if I have opposites, if they look the same, b plus 1, b minus 1, they almost look the same. The only difference is that they have opposite signs in the middle. And so we can sort of think about, well, we might have some canceling out, and that's what happens in this example here. This one, not the same as the last example because they both, again, have to be p minus 4 times p minus 4. We have p squared, and that idea of -4 and p, so minus 4p, and we have them twice. -4 times -4 is a positive 16. P squared minus 8p plus 16. Final answer. So we're just looking at some different ideas. Pause the video, take a look at the next example in the column, and we'll come right back. So this one, it should have worked out as we did in the last chapter, but what's interesting is this would not be a final answer when we get to chapter 8 and have to work backwards. We might have seen this written like this. So these are two equivalent statements. Since both binomials are the same, then I can write it as the binomial squared. First outer inner last, L squared plus 2L plus 2L plus 4 gives me L squared plus 4L plus 4. Take a moment, try the next one, and we'll be right back. So we do have, again, the idea of a coefficient this time, which we didn't have on the other one, 2k minus 2 times 2k minus 2. So again, if I'm thinking about my first two terms, we have 4k squared. But again, this idea in here, knowing that they're both going to be the same for inner outer, I have a minus 4k, another minus 4k, plus 4. So remember that outer gives me 2k times -2. The inner gives me -2 times 2k. We have 4k squared minus 8k, no k squared there, plus 4. Remember when we are and are not allowed to add our exponents. Now let's take a look at 21. 21 has a variable on both, but it doesn't change the way we look at this one. Two terms. And first two terms are x squared. My outer two terms give me a -4, and usually we write them in alphabetical order, so x, y. My inner two terms are going to give me the same thing. Order does not matter with multiplication. X, y is y, x. And then my last two terms, a plus 16y squared. Take notice to how we have two squared components where we didn't before. We need to simplify x squared minus 8xy plus 16y squared. Let's take a look at another example. Now, this one is similar to the one we had with b plus 1, b minus 1. They are identical. binomials except for the middle. And so what's going to happen is this guy is going to have some canceling out. 3y times 3y is 9y squared, guys. Inner two terms, 3y, or the outer two, 3y times 3g is a positive 9gy. Inner two terms, negative 9gy. Last two terms are negative 9g squared. This is using some of our old ideas back from previous lessons. Simplifying, we have 9y squared. These two cancel each other out because of the opposites. Having identical binomials with opposites, then my inner and outer terms are actually going to cancel themselves out. This later we will look at as being the idea of the difference of two perfect squares when we get into the next chapter. Last but not least, we have a lot going on inside of this one. Again, we rewrite it as if it were 2 so that we can do our first, outer, inner, last. First two terms, 4k squared. Outer 2 give me 2km squared. Inner 2 give me 2km squared. Last 2, it's a 1 times a 1, so it is 1m to the 4th power. Now, because they were both positive here, that means we do have to add our outer and inner terms. 4k squared plus 4km squared plus m to the 4th power. Final answer. Your homework is to work on the evens, 2 through 26. Good luck.